There is a very common saying that there is good, fast and cheap. You can only have two of those three. Same goes true for the CAP theorem that deals with distributed systems or cloud computing systems. So CAP theorem is nothing but the relation between consistency, availability and partition tolerance. Again, it also says the same thing, that out of these three things, you can only pick two. If we have to understand CAP theorem in the simplest terms, you can just understand with this figure. You can clearly see that at any given moment, you can either have consistency and partition tolerance, you can have consistency and availability, or you can have availability and partition tolerance. All three are not possible together because of all the trade-offs and all the constraints that we have to achieve these abilities. Now, this is the whole definition and meaning of CAP theorem. So if you have good enough understanding of system design and distributed design concepts, I think you can end this video over here. For those who are still in the beginner phase and who wants to know that why these three things don't go together, I'm going to give you a detailed explanation for each one of the properties, what they are, how they interact, and what are the trade-offs you have to consider. So if you want to understand more and dive deeper into the concept, you can feel free to watch the rest of the part. So before understanding the combination of different values, first let's understand that what does consistency, availability and partition tolerance means, that all of them combined create this CAP theorem. Well, the consistency is nothing but for any particular system to always return the same value of data, no matter how many times the update or delete operation happens. So we all know that in distributed systems, we have multiple copies of data, not just one copy of data. Now, how would consistency occur is, let's assume that I'm currently a user and my previous name was Twitter, but now from Twitter, I decided to change it to X. Now, in terms of if we are following the principle of consistency, which means the moment I submit a request that, hey, instead of value number Twitter, return the value number as X, the transaction would go through. There would be like a lot of complex mechanism that happens, but eventually it would start updating the database. So it would first update this database and where the value would be X. Then again, same update will also happen in all the copies of the same database as well, and all the databases would be marked as X, and then only we can conclude that this transaction has completed. Now, after completion of this transaction, no matter how many times or how many different geographical locations I try to see that what is my username, I should also see the value as X, because I am going to be fetching through any data. All of the data has been updated, which means consistency across data has been maintained. Now, second concept of availability is very simple, that no matter how many system failure happens, the system is always going to be available to me. So let's assume that again, I'm trying to use the Twitter system. Now in this case, Twitter system is currently running on multiple nodes and there is a lot of processing happening behind the scenes, right? I'm unaware about that. All I care about is my Twitter app on my phone. So let's assume for some reason some network outage happens, some crash happens, and suddenly all of these nodes are no longer available. Still, because I had replicated copies, I should still be continued to use Twitter ecosystem as it is, because I had multiple copies distributed, like geographically located at multiple places. So even in any scenario, Twitter might not be very fast, but still it would always be available. If I have multiple copies running, or all of them are receiving the load and all of them are geographically distributed, that means I can say that my Twitter system is available. And typically availability of any system is marked by the number of nines it is available as. So let's assume that if the Twitter is available for 99.99% of time in a year, which is considered to be a very good availability, then we can consider it to be available for that much value of time. And this is usually defined as 4 nines. There are also like 5 nines, there are 3 nines. So there are a lot of different types of availabilities, but this is typically considered to be a very good availability. Now, the last one is a partition tolerance. So partition tolerance means that let's assume that currently I'm using any particular ecosystem. Let's once again assume Twitter. Now again for Twitter, let's say that there are 4 different nodes that are currently running all the servers and all the databases are connected through nodes, and there is a lot of networking going on, and internally they are also talking with each other for various different functionalities and whatnot. Now suddenly for some reason some network partition or network failure happens. So the ability to tolerate that network partition or network failure is defined as partition tolerance. So once again, let's say for an example, if these two nodes are no longer available, still network should be able to talk with each other, communicate with each other, and these servers are currently not available, so they should be taken out of the network and then eventually bring back to the network. And from the user's point of view, no effect has happened, so the network partition did not had any impact on the user functionality. And this is what consistency, availability, and partition tolerance means. Now let's try to start talking about their combinations. So first combination is consistency and availability. Now we all know that in order to achieve consistency, we will have to update all the copies of any given database with the same value. We know the concept of availability means that for any particular copy, we will need to have multiple copies of that value. And this is how we can achieve that this availability means that the multiple copies needs to be geographically distributed. There needs to be a load balancer that takes care of routing the traffic to multiple copies for each transactions. And then we are also doing a lot of processing and a lot of servers are available. So if some servers go down, we can take care of other servers. Now we know that we can achieve consistency and availability in this scenario, right? But the question is, why are we not able to achieve the partitioning of network or partition tolerance in this scenario? That is a critical part to understand. Now think of the basic trade-offs we are making. We want to ensure that consistency is there, which means whenever we are trying to make any particular change, that change has to be replicated in all the available databases on all the available copies. Now availability means we need to have multiple copies of such server available and up and running. So we are not only dealing with just one set of database, we are dealing with multiple databases. Consistency doesn't care. If the system is down, which means still it can be a consistent system because it's not updating the data. It does not have stale data. But availability means that system has to be up and running. So for that we have this multiple copies. Now for some reason, if partition happens in the network, which means this server that was originally available to us that contains the data is now no longer available for some time. And meanwhile, which means if we have to update any data, so we have to maintain the consistency. In that scenario, we will need to update this database. We will also need to update this database, and we will also need to update this database. But since this database is no longer available, now in this case, we can either choose not to update the data entirely. So if we decide that we are not going to update this new data entirely, then we would be having issues with the availability, because that means our systems are no longer available. And if our systems are available, but still we won't be able to be consistent. So which means whenever we need to create a consistent and available system, we cannot allow any network failures or any partition tolerance. Like the partition tolerance is basically zero in this scenario. Now let's take another example, and now all the examples would be simpler for you to understand. Now let's understand the scenario of consistency and partition tolerance, that we are able to do that. But in this case, we would not be able to achieve availability. And why this happens? Once again, when we need to have consistency, we need to make sure that the data is updated in all the multiple copies. And we are having multiple copies not only because availability, but because also for disaster recovery. What if this entire database crashes? You need to have multiple copies because you cannot afford single point failures. So now let's assume that we have 3 copies of the database. Currently we have our networking being done, and networking is sending out the data to all of these places, and we have the ability. Now if I want to update the value from A to X, in this case I need to update in all of these 3 places. And until that is because we are following the principles of consistency. Now for some reason, let's assume that there happens a partition in our system. So the moment a partition happens, which means currently one of the server's network link is no longer available. Now in this case, if we want to make another change from X to value number B, we would not be able to make, because we can update these 2 databases, but we cannot update this data because this networking node is not yet not yet available. So we will have to wait for that time. And because we will have to wait for that thing to finish, then that's why we cannot achieve availability in this case. So that is a trade-off. If you want to have a consistent system that can handle network failures, which means that there might be some instances where that system would not be available. And same goes that if you want to have an available system that can handle partition network failures, so in that case consistency would not be maintained basically. And why that is the case? Well, once again, if there is availability, we have multiple copies of multiple web servers and databases geographically distributed on different locations. On top of it, we have the network that is currently connecting with all of the available databases. Okay, there is a lot of networking nodes. Just think for an example. Now we want our systems to be available, which means our servers has to be up and running all the time. We can tolerate some potential failures in our network as well. So let's assume that if this piece goes down, still our servers are available because we have other servers that are taking care of it. The only fact is these servers, they are just no longer connected with the network. But in this case, if we want to achieve consistency, it would not be possible. Why? Because the same reason, there are some servers that are not available, and if we have to have a consistent system, then we need to update them simultaneously in a single transaction or in one go. So it would not be possible. So these are the reasons on why we cannot achieve consistency, availability, and partition tolerance at the same time. And this is what CAP theorem means. So the purpose of CAP theorem is to help you understand that whenever you are designing your own systems, what are the trade-offs you are going to consider. And these are some of the most significant trade-offs for designing any particular system. Now, microservices is one of the most popular system design pattern right now. And you are building a lot of complex system with loosely coupled microservices that serve some sort of business functionality, which means in many scenarios, in many of your microservices, you might be more concerned about consistency and availability rather than tolerating network failure. Or there might be some instances where you are more concerned about consistency and partitioning tolerance for any particular network, even if availability can be compromised. So it's always understanding and judging these differences and these trade-offs between any particular system that you are trying to build. And the purpose of this video was to give you an example of what are the different things are. And now let me just quickly show you that what are the combination of each three types of databases, and then we would wrap up this video. First, let's see an example of consistency and availability. These are your common SQL databases like MySQL, SQL Server, or Oracle. They are really good in terms of both consistency and availability. Next one is consistency and partition tolerance, or CP. So these are your common Redis or Apache HBase or MongoDB. They provide sufficiently high levels of consistency, and on top of it, they can also handle partition tolerance or network failures. And last one is availability and partition tolerance, and these are your very well distributed large language systems that are highly available, but they don't provide much consistency, and all of them are NoSQL databases like Cassandra, Amazon DynamoDB, or Couchbase, and they are really good in terms of availability and partition tolerance. So I hope you gain good insight on what type of different options you have while designing your system, and let me know in the comments if you have any feedback for me so I can include that in my upcoming videos. Till then, thank you.